Okay, this is the UK Math Trust Pink Kangaroo paper from 2020. It's the extension for the intermediate challenge if you're in years 10 and 11 in England and Wales. I think it's slightly different for Scotland, but whatever. You don't lose any marks for getting anything wrong here, so you may as well just guess whatever if you're not sure. You won't lose any marks. This paper is quite a bit more difficult than the intermediate, but it's nowhere near as hard as the 2021 version of this paper was. At least in my opinion. Let's get into it, and we can see that with the first question. The first question from 2021 was a combination of means and you had to work out some totals. This is just counting. You count some sides. Good. Question number 2. When these were in order, so I mean, you can probably consider these in some intelligent way. I didn't. I just added them all together and then said this is the smallest, then this, and so that's the one in the middle. So it's B. Question number 3. So if we look at this sum, k plus m is 9 or 19, except it can't be 19 because 9 and 9 make 18, you can't have a digit of 10, so k plus m must be 9. I say 19 because then you could carry the 1 down, but it's just 9 because you can't get that. Here we have m plus k, which is just 2 lots of m plus k, or k plus m, so we have that 2 lots of that must be 18. So we've got an 8 there and then a 1 down here, and then we have j plus l is 7. Again, it can't equal 17 because then you'd have a 1 here, so it must just be 7. And then this is j plus l plus j plus l. It's the same trick, it's just twice this because there's twice as many letters there, so it's twice it. Add the 1 to make 5 and then put the 1 over and you get 158. Good. Question number 4. I mean, I don't know whether there's an intelligent way of doing this. I just worked out that -1, 0, 1 and 2 are 4 consecutive integers that add to 2, and then of course the lowest is -1. Good. Question number 5. So, I mean, yeah, I'm a bit confused about this question because I'm not sure whether it's, I mean, is it not obvious that this is the next number that does this? And is it also not obvious that that's 101 years after that? I'm a bit confused. Anyway, question number 6. Mary had 10 pieces of paper, some of them squares, rest triangles. So if we call the number of squares s and the number of triangles t, s plus t is 10. She then cut 3 squares diagonally, because there's 10 of them. She then cut 3 squares diagonally from corner to corner. Now when you cut a square in half, you make 2 triangles. So what she's going to do is she's going to reduce the number of squares by 3 in order to increase the number of triangles by 6, because for every square that you lose, you gain 2 triangles. And essentially this is just this statement, but written in a more fancy way. It's just updated here. She then found the total number of vertices. Now squares have 4 vertices, triangles have 2. So of these things here, 4 lots of this plus 2 lots of that is 42. Sorry, plus 3 lots. Triangles have 3 vertices, I should say. So 4 lots and 3 lots. Squares have 4 vertices, triangles have 3. So okay, let's expand that out and collect it and tidy it a bit. And now let's go back to this original equation, just because it's more simple to work with than this one. If we times it all by 4, we get this, and then we just look at the difference here. The difference is 1t and the difference is 4, so 1t is 4. So the number of triangles we started, it was 4. Good. Number 7. So times both sides of this equation by CD, because that gives us ABCD. And now here I notice this is actually CD times CD, or C times D times C times D, which is just CD squared. And so ABCD is twice a square number, because CD is just an integer if these are all integers. So ABCD is twice an integer squared, or an integer squared times by 2 is what I should probably actually say. So all of these answers, it have to be, if I halve them, I have to get a square number. So okay, I halve that and get 25, that's square. I halve that and get 50, that's not square. So 100 is the answer, because it's not double a square number. This is double 100, which is square. This is double 225, which is square. This is double 400, which is square. But this isn't. So the answer is B. Question number 8. If we just sketch this question very quickly, we have a line with towns A, B, and C on it. And somewhere on this line are these 2 signposts. Let's just put this one here. Let's call that signpost X and put it here. So there's 3 kilometers this way to there and 1 kilometer this way to there. And then 9, I guess, all the way to C. This signpost B is in the other direction, so it must be on the other side of B. So I'll put it here somewhere. Now, importantly, it's, as I said, it's 3 kilometers to that. And now it's another 3 kilometers from Y to X, because it's 3 kilometers further to get to Atown. So it's just 6 in total to get A, or just 3 and 3. Now it's B from X, it's 1 kilometer from X to B, as it says there. Which means, of course, just looking at this, if it's 3 kilometers there and 1 there, then it must be 2 kilometers to B from the signpost Y. So it's 2 kilometers. Number 9, so we've got an isosceles triangle with a side of 20, so something like that. Of the remaining two sides, one is equal to 2/5 the other. So if one was x, the other was 2/5 of x. Now x doesn't equal 2/5 of x unless x is 0, but then this isn't really a triangle. And now this triangle is isosceles, so if x isn't equal to 2/5 x, then that means that either x is 20 or that 20 is 2/5 x. Because I need either these two sides to be the same or these two sides, because these two can't be. So either x is 20, in which case this side is 2/5 of 20, which is 8, and then the perimeter is 20 plus 20 plus 8, which is 48, which is one of the answers. But what about the other situation where this side and this side are equal? So 2/5 x equals 20, or if I times by 5, that gets me 100, divided by 2 is 50. And so I get side lengths of 20, 20, 50. And the perimeter, therefore, I don't know why I put x is 50 twice. The perimeter, therefore, is 90, which is another answer on this list. So how do I know which of the answers it is when both of them seem reasonable? Well, I look at this and I think, actually, this isn't a triangle, mate. This isn't a triangle. Because if we consider this point to this point, the shortest distance is the straight line. So the shortest distance has to be 50 between these 2 points. But apparently if I go all the way over there and then all the way up here again, I get a distance of 40, and that's less. But it's not, because I'm going off track here, aren't I? So this isn't really a triangle. And so the answer is the first one of 48. Good. Question number 10. So again, one of those questions where there's probably more intelligent things to do. I just thought, well, if there are 8 numbers around the outside and they add up to 40, 40 divided by 8 is 5. So let's just try shoving 5s into all of it. That makes 40 certainly all the way around. And if the 3 numbers on each diameter make 13, well, currently they all make 10. So putting a 3 there works really well. And so a 3 must be the thing written in the thing, because that's the thing I have here. There are probably much smarter ways you can do that. I mean, you can... It's completely unnecessary, but you could try and justify that why 3 is the only thing that can be here. Like, if you increase this 5 by 1, you have to decrease another 5 by 1 to make this still 40, but it has to be this one, right, that you decrease, because you have to keep this at 13. And whatever you do, this 3 kind of stays constant. But again, this is a math challenge. We're aiming for as many correct questions as you can. You don't need to go over the top and prove things that it's not asking. So we'll just leave it there. Question number 11. This person put a multiplication sign between the two double digits in this 4-digit number, and notice that 20 times 20 is a square number. Of course it is, because it's 20 times 20. How many integers do this? Now, to answer this question, we just need to have a quick rethink about what a square number is, because it's not necessarily a number multiplied by itself. For example, 2 times 8 is a square number. It's 16, but it's not a number multiplied by itself. It could be. It's the same as 4 times 4, but it doesn't have to be written as that. You can write it as 2 times 8. And now, what a square number really is it's a number where, when written in prime factorization, every prime has an even power. So, for example, 100 is 2 squared, even power, times 5 squared, even power. 64 is 2 to the power 6, that's an even power. 144, 2 to the 4, even power, 3 squared, even power. You've got all these primes in even amounts. The reason they have to be even, of course, is because then when you split 144 into 2 12s, you can distribute and split up these primes equally. You can share them equally amongst the two piles, essentially, to make a 12 on one side and a 12 on the other, because there's no odd ones out, right? So they have to come in even pairs. So now we consider, every number between here has 20 as its leading double thing. So 20 is 2 squared times 5. So when I multiply 20 by something else, n, so I'm going to break the 2000s and whatever up into 20 and this number, it's going to be 2 squared times 5 times n. And I'm looking to make this whole thing be square and therefore have these even power systems in the product. So n is 5 will clearly do this. I mean, it has to have a 5 first. It must have a 5 to even out this 5. So it must have a 5. N is 5 would work, but that would make the year 2005, which isn't in the list. I have to start at 10. So then I think, well, what else can work? Well, if I use a 5, but then also use another 2 2s, because that will make the overall power of the 2s 4, because there's 2 here and 2 there, and it'll make the 5s 2, so that would be square. And that's, we've already seen, that makes the number 20, so that makes the year 2020, which is the one that they've given me. So then I go to the next one, I think, well, I'll add a 5 in, again, to even out that 5, and then add in 2 3s. And that's 9 times 45, 9 times 5 is 45, so that makes the year to 2045, which works. 20 times 45 is a square number. And then the last option I could go with was adding another pair of 2's in, because that means 2 squared is 4, 2 squared is 4. I'm adding in a factor of 16 here. Times 5 is 80, so that makes the year 2080. I could try the next thing, which would be adding a couple of lots of 5 or a couple of lots of 2's plus a couple of lots of 3's, but then I get over this amount here. And so there are 3 years that do this, 2020, 2045, and 2080. Question number 12. I've seen a question like this a few times in these intermediate math challenges. It's an equilateral triangle, so that angle is 60. This is a right angle because these are squares, which means that's a right angle. This is a right angle because it's a square, which means that's 270. And now this is a 1, 2, 3, 4, 5-sided polygon, so let's do 5 minus 2 times 180, which is 3 times 180, which is 540, and then just take away the angles that I have, and I should get this one here. And I'll get the angle of 50. Good. Question number 13. So Luca began this trip with 14 litres of fuel. A car consumes 1 litre for every 10 kilometres. So if they've got 14 litres, times that by 10 to find their current range without filling up is 140 kilometers. Now, after driving 55, so if we take away 55, their range will be 85 left. He saw a road sign to these petrol stations. Now, he wants to stop just once to fill the tank, so it's logical that he'll go as far as possible before filling up so that he can fill up as much as possible when he does, because his fuel tank will be more empty the further he goes. So he can't get to the 95 kilometer one because he's only got 85 left. So he has to maybe go to the 75 kilometer station, and we'll just check that this works. If he goes another 75 kilometers, he'll have 10 kilometers left in the range, which is 1 liter of fuel because 1 corresponds to 10. His fuel tank is 40 liters, so he can add in another 39 liters, which will give him his fresh maximum range of 400, just 40 times 10. And just check that's far enough to get the whole trip. Well, he's done 55, he's done 80, he's then does another 75. So he's done 130, take 130 away from 520, and we get 390 kilometers left on the journey, which he can just about manage with 1 liter of fuel left, or 10 kilometers worth. And so the answer is D. Okay, so X and Y satisfy this. First thing I noticed here is I can factorize out a 17 from these two. 51 is 3 times 17, pretty disgustingly. So I can do that, then I can divide by 17, and even more disgustingly, 102 actually does divide by 17, exactly 6 times. So x plus 3y is 6, and then looking over here you just notice, oh well, that factorizes as well to 9 lots of x plus 3y, but I know what x plus 3y is at 6, 9 times 6 is the answer, which is 54. Question number 15. So we're looking for the distance from this bit here down to the bottom. So I'll call that x. And this window pane is area 81, and it's a square, so the two sides are length 9. Now what I need to notice here is that this triangle here, this grey triangle, the light grey one, and the dark grey triangle have the same area, because all 6 triangles have the same area. Now, to work out the area of either of these triangles, you would do a half times their base, their respective bases, these two things here, times their height, but their height is the same. Their perpendicular height is just the same. And their area is the same, and half is the same, so their bases must be the same. And therefore their bases must be 4.5, because we're sharing a base of 9 here. So that's cool, and you can make exactly the same argument with these two triangles, though I think it's unnecessary thinking back at this, because now what I can say is, well, the area of this triangle is a half times 4.5 times x, and the area of, say, this triangle, if I call that y, is a half times 9 times y. So those two things are equal, because this dark grey square equals this dark grey square in area. And if I cancel the halves and divide by 4.5, I get 2y equals x, but I know x plus y is 9, just based on this. So x, sorry, I should have written a line here, x plus y is 9, but x is 2y, which I have immediately put in there, so 3y is 9, so y is 3. If y is 3, that means x, the original thing I was looking for, is 6. Question number 16. So the digits from 1 to 9 are randomly arranged to make a number, 9-digit number. What's the probability the resulting number is divisible by 18? So to be divisible by 18, because 18 is 2 times 9, you need to be divisible by 2 and divisible by 9 at the same time. Now, The divisibility check for 2 is easy, it just ends in a 0, 2, 4, 6, 8. Now, none of these numbers end in a 0 because we're taking digits 1 to 9, so it has to end in one of these 4 digits. To be divisible by 9, your digit sum has to be divisible by 9. So if you add up the digits of the number, it has to be a multiple of 9. Now, if we add up the digits from 1 to 9, we get 45, which is a multiple of 9. So whatever order you put these 9 numbers in, it's going to be divisible by 9. All of them are. So this is not even a check that we have to do. We just check that it will always work. So all we're actually looking for is for the number to end in a 2, 4, 6, 8. Now, these are the numbers here. And 1, 2, 3, 4 of them are a 2, 6, 4, 8, and 5 of them aren't. So, and there are 9 numbers in total, so 4/9 end in the number we need them to, and that will be our answer. Question number 17. So this is a great math challenge moment where Mr. Drew just makes up a random number because it's really easy to. The distance that the hare goes is 5 kilometers due north, and we'll just say that the tortoise. We'll just say that the tortoise goes at 1 kilometer an hour because that makes it super easy based on speed distance time to say that the tortoise takes 5 hours to do this. Good, okay, so the tortoise has taken 5 hours to do this journey. The hare goes due east, which I now realise is not this direction, but I hope we can realise it's not going to make much difference. If the hare goes 5 kilometers, 5 times as fast, we'll say that it goes 5 kilometers per hour, goes in this direction, then after a bit it decides that it actually needs to go in this direction, and again, this is why the east thing doesn't matter. I just realised that I've now messed that up. But anyway, it goes 5 kilometers an hour along both of these bits here. And now we know that it takes 5 hours to do this because they finish at the same time. So in 5 hours, this hare goes here and here. It's traveling at 5 kilometers per hour all the time. So 5 kilometers per hour for 5 hours means it goes 25 kilometers. So this across here and then up here is 25 kilometers in total. So if I call this distance x and this distance y, I know x plus y is 25. And then because there's a right angle here, I also know 5 squared plus y squared is x squared, or x squared minus y squared is 5 squared. Now, as soon as you see this in a math challenge, you go ahead and do it. You could rearrange this for y and substitute in, but no. You see this, you do this. It's difference of 2 squares. X plus y is 25, so let's put that straight in there. And then, of course, divide by 25 makes x minus 1, y 1, which means we're looking for 2 numbers, x and y, that add to make 25, and subtract to make 1, have a difference of 1. That's going to be 12 and 13, I believe. 12, x being the bigger one, because it's on the hypotenuse. And now we see we've got the 5, 12, 13 Pythagorean triple. So x is 13. I think that's the distance from his finishing point to the point he turned. Again, the east-west thing doesn't matter, but the distance will be 13. Question number 18. So, okay, this is just a quick logic check. If the shape is large, it's a square, is one rule that you have for these pictures here. What that means is there are no large triangles, because if the shape is large, it is a square. So there are no large triangles is the kind of thing you can read from that. If the shape is blue, it's a triangle. So what that means is that there are no blue squares. If the shape is blue, it must be a triangle. So no blue squares. And then you can look through these and you can think, well, which ones are going to work, which aren't. Or the other way to go about it entirely is to draw a picture that obeys these 2 rules. So here's a random picture I drew that obeys both of these rules. If the shape is large as a square, there it is. That's the only large one. I'm going to say these are all small triangles and this is a small square. So that's the only large one. If the shape is blue, it's a triangle. Again, this obeys this. If the shape is blue, it is a triangle. That does it. And now we just read through these. All red figures are squares. Clearly not true. Because, yep, look at it. All squares are large. Again, clearly not true. That's a small square right there. All small figures are blue. Not true. Got lots of small figures that are red here. All triangles are blue. Not true. Here are some red ones. All blue figures are small. Now that is true here. The only blue figures are small figures. Does that work for this logic? Well, yeah, it does. Because essentially, if you were to have a large blue figure, it would have to be a square, because we know squares are the only large things. But we're not allowed to have a blue square. So these rules work perfectly to give us this rule here. And that's question 18 done. Question 19, thought this was quite a hard question actually. First, what I set out to do, that's length 3, and this is length 9 is what the question says. First, what I set out to do was quickly prove that these white triangles are congruent. That means they're identical. So how do I do that? Well, they all have right angles, which is good. So that's one thing that I need. If I call this angle, so this is the same as this and the same as this because they're just all the ends of the same rectangle. So they all have right angles. They all have a side that's the same here. So I've got one angle and one side the same, which is good. If I call this angle x, this is because of vertically opposite, but so is this because these are parallel sides, of course, and so are these because they're rectangles. So that's corresponding, and then this is vertically opposite. So now I have two angles and a side shared. That's ASA, or whatever. If you have two angles shared as well, you have a third one shared, and then you've got a side that's the same. So these are definitely congruent triangles, which means that this side is the same as this side, the same as this side, the same as this side. So those are all the same. Which was really important for me to get. It's also important that I know that this side, this side, this side, and this side are all the same, again, because they are part of congruent triangles. So let's put that down. So if that side is x and this side is y, then this side is also x, because we just said that those two sides are the same, and this side is also y, again, because those two sides going around are the same as well. Okay, so I know that x plus y is 9, because clearly, it's just the length of the rectangle. I know this distance is 3, and so the area of the shaded region is just x times 3, or 3x, just base times perpendicular height. So if I could just eliminate y somehow and find x, then I would be able to put it in here and find the area. So what else do I know? Well, looking at this white triangle again, there's a right angle down there, which means x squared minus y squared is 3 squared, which is 9. And again, we see the same setup, x squared minus y squared, that's the difference of two squares that. And again, exactly the same trick as 2 questions ago, actually. Just put the 9 straight in there and you get x minus y is 1. And again, you're looking for two numbers with a difference of 1 that sum to make 9. That's going to give us x is 5, y is 4. So we must have 5 and 4 here. If x is 5, then we just do 5 times 3 for our area, which is 15. So exactly the same trick, 2 questions out of 3, which is kind of interesting. Question number 20. So we've got a square-based pyramid, and I'll just put A, B, C, D as the numbers that represent 1, 2, 3, 4, 5. Now the first thing I look at is, okay, well, if the base was the face that added up to make 10 here, because the faces are adding up to make these numbers, but there are only 4, not 5 given. If the base was the one that made 10, then the base would have to be 1, 2, 3, 4. The base can't add up to make 9, 8, or 7 because your numbers aren't small enough. So the base would have to be 1, 2, 3, 4 to make 10, which would make E 5. But if E was 5, then you couldn't make another face 7 because you'd have to have 5 at the top and then like 1 and then you have a 2, but that makes 8. So this can't happen. So the triangle face, whichever one it is, can't be 7, so the base can't be 10. So what that tells me is that these 4 faces they've given me, these face sums, or whatever we want to call them, they're all the triangular ones. We haven't got the square one. Okay, so that's the first thing I'll say. Then what I'll do is I'll just add up all of the triangle faces. So A plus B plus C is the front face here, A plus D plus C is the side over there, B plus C plus C is this front, and then D, C, E is the back there. All of those, if I add them up, must make the sum of adding these up, which is 34. And now when I add these up, I notice I get 2 A's, 2 B's, 2 D's, 2 T's, and 4 E's. Now I can factorize that in quite an intelligent way. I can say it's 2, lots of all of them, plus another 2 E spare. But I know that all of them add up to 1 plus 2 plus 3 plus 4 plus 5, which is 15. And that should definitely be a 2. Apologies, that 2 should just be a 2 here, so that's a typo. Sorry, so that 2 should be a 2, which makes it 30. Take away 13, get E is 2. So I know E is the face with 2 at the top, is the one with 2 as its number, which means these 4 numbers are 1, 3, 4, 5. Which of course add up to, and it's asking me what the sum of the fifth face is, which I've already decided is the bottom one. Those add up to make 12, or sorry, to make 13. Apologies for the typo on this page. Question number 21. A large cube is built out of making 64 smaller ones. So here's a large cube. Let's split it into 64 smaller cubes. That means using 4 along the base, 4 along the height, and then 4 along the third dimension there. 4 times 4 times 4 is 64 cubes. And now let's just paint the front 3 faces. So let's pretend that this is actually a white cube. I've just painted the 3 faces you can currently see blue. Now, okay, how many cubes have one face painted blue? Well, the problem is that this cube has 3 faces painted blue, so that doesn't count. And all of these ones on the edges all have 2 faces painted blue, so they don't count either. So the only faces that have 1 face painted blue are these 9, and these 9. So that's 3 times 9, 27 faces painted blue. And now the question is, that is an answer, but it says what's the maximum possible. And it seems like the question is, if you paint 3 different faces, can you end up with more that only have 1 face painted blue? And the answer is yes. If you don't paint them to make a corner like this, if you instead paint them maybe in a line, so I painted this face blue, and maybe this face on the other side blue, so I've painted a U shape rather than just one thing that you can see. And let's count up this. Well, again, these kind of edges will have 2 painted, so I've painted this backside as well, so those will have 2 painted, and so will this. But everything else will only have 1. So all of these 12 only have 1 face painted, because there's nothing below or to the side of them, so there's 12 there. There's 8 here, these 2 rows of 4, and then there's 12 on the back here, exactly the same as here, and 8 plus 12 plus 12 is 32, and I think that's the best I can do, because the only 2 ways to paint 3 faces of a cube are the first one you saw where you join a corner like this, or painting them in an arc like this, again because the cube is just symmetrical. You can think about it, but I don't think there's any other way to paint a cube than just doing one of those 2 options. Okay, question 22. So this is kind of like a magic square. The rows and the columns add to make the same thing. So if I call this one x, I know that the sum of this magic square in rows and columns is 10 plus x. So now if I call maybe this one z and add up this row, I get 15 plus z, which means that if this is going to be the same thing as this, that means z is going to have to be x minus 5. It has to be 5 less than x. For example, if x was 8 to make 18, z would only be allowed to be 3 to make 18. So z is 5 less than x. So that's good. And now I'm going to look at this number, which I'll call y, and I'll add up this row, I think. Yeah. X plus 2 plus 7 plus y, add up that to make this. And now again, this has to be the same as this, which means y is going to have to equal 1. If we just cancel the x's, y has to equal 1. So I can get that this one must be 1. And now finally I can do this row to try and find this number, which I'll again just call y because I've have no longer use for the other one, the other y that I said. That's going to be that if I add up those sides there. And again, that simplifies to this, but it must equal this here. And again, the x cancels, and you get y is 7. So the shaded cell is 7. Excellent. Question number 23. So these people are having an arm wrestling contest. The winner keeps playing, and the person who loses rests, and then they just keep doing that over and over, and they play this many games. Now, if we add up these numbers here, we get 42. But each game takes 2 people, so if we divide that number by 2, we can find out that 21 games were played of arm wrestling. Now, the key here, it seems tempting to think about Kathy because she played almost every game, but the key is to actually consider Alice. She only played 10 games out of 21, which means because 10 is actually less than half of that, she must have lost every single game she played. And even more than that, because she must have literally got up to play, immediately lost, and then had another rest game. So she rested 11 times and played 10. She must have just been played, rest, played, rest, played, rest. Like, she can't have ever won. And actually, even more than that, because she played 10, rested 11, she can't have even played the first game. She must have been rest, play, rest, play, rest, play. She must have played in these games here, 2, 4, 6, 8, 10, and so on, right? Because that's 10 games in total. And then she rests on the 11 odd numbers in between. So she can't have been playing in the odd numbers because then she'd have played 11, rested 10. So she must have been playing in these games. I mean, that actually just gives us the answer straight away because this means the first game was played between Belle and Kathy. We don't know who won that. Maybe there's a way to figure it out. I'm not sure. But in either case, someone won and then they played Alice. But we know Alice lost that because she lost every time. So Alice definitely lost the second game. Good. Question 24. 8 consecutive integers have a property. Each of the divisible by the last digit. So, okay, so there are 3-digit numbers and 8 numbers in a row, three-digit numbers are divisible by the last of their digits. Now, if a number ends in a 0, that would suggest that it's divisible by 0, but of course you can't divide by 0. So none of these numbers can end in 0. But if there are 8 consecutive of them, then that means that they must either be of this form that goes from 1 to 8. So there must be a string of numbers ending in a 1 all the way to ending in an 8. Or they must be of this form starting at a 2 and ending in a 9. Now this immediately looks more promising to me, because I'd have to check that this number was divisible by 1, but of course every number is divisible by 1. So that's fine. And if this was the case we were looking at, then again, as I've just said, all numbers are divisible by 1, so this would actually give us a string of 9 numbers that are divisible by their last digit. So it can't actually be that. It must be of this form. The next thing I thought was actually, okay, well, any number that ends in a 2 is divisible by 2, because numbers that end in a 2 are even. So this isn't going to be a problem. And nor is this, because any number that ends in a 5 is divisible by 5. What is actually going to be the problem here? Well, probably the 7. We all know dividing by 7 is annoying. The 7 is probably going to be an annoying thing here. I need to find three-digit numbers that end in a 7 that are divisible by 7. So that was my logic here. I thought, okay, well, 140, obviously going 70 to 140, 147 is divisible by 7. So let's shove the numbers 147 and then all the numbers next to it into here. And likewise, the next one I'll get to in a second. But 147, this doesn't work, because the only other divisibility check that I know, and the only one that I know really that I'm going to use here, is that for a number to be divisible by 3, all the digits must sum to something that's divisible by 3. And these don't, right? 1 plus 4 is 5, plus 3 is 8. That's not a multiple of 3. So actually, what I'm going to do is I'm going to look for three-digit numbers that end in a 7 that are divisible by 7, and I'm going to do that just by adding 70 to the 2 that I've started with. But I'm not going to test them all. I'm just going to look at the first 2 digits, and if they sum to something that's a multiple of 3, then at least it passes the 3 check. Because this number ends in a 3, so that just adds a 3 to it, which doesn't make a difference. So for example, this works because 2 plus 1 is 3, and then I'll add another 3, but of course that's divisible by 3. So this is worth checking, because 2, 1, 3 at least passes that check, because the 2 and the 1 add to make a 3. Everything here is good, except up to here. I'm just going to divide by 2 to get 107, and then divide by 2 again, but 107 is odd, so this actually doesn't work. So then I look for my next multiple of 7 by adding 70 to this, but again, these 2 digits don't add up to be a multiple of 3. So the 283 that I'd have here is not going to be divisible by 3, so that's not worth looking at. Nor is this, because they add to make 8, which isn't a multiple of 3, but this does look worth checking. So let's check this one. And again, 1 is fine, 2 is fine, 3 is fine, as I've said, 4 plus 2 is 6, plus 3 is 9, so that's fine. If I halve that, I get 212, which I can then halve again for 106, that's fine. In fact, it's all fine all the way until this one, I believe, which if you halve, you get 214, half for 107, and then that doesn't halve one last time as you would need for an 8. So this was almost okay, but didn't work, so I'll try the next one. Those don't add up to make a multiple of 3, so I ignore it, nor do they, so I ignore it. Look at this one, they do, so I finally check that one. These all look good, that adds up to be a multiple of 3, so that's fine. This is all fine, this is all fine, but unfortunately it doesn't quite work here again. Halving it doesn't quite make an integer, so you have to keep going. That's not going to work because those don't make a multiple of 3, nor do they. Finally, this one does, again, to make a 12 here, so 843 will definitely work. Check this. And finally, if I halve that 3 times, I will get an integer. Finally, so I found the one that I was looking for. It's the one starting at 841 to 848. The sum of the first one's 8 plus 4 plus 1, which is 13. Now, it should be said that that's how I did it. There's much more intelligent things to do here, including noticing that if all of these numbers are divisible by their last digit, then, for example, this one, when you take away 3 to get, in our case, 840, that must also be divisible by 3. And so what you do is you check that you try and find a number here that ends in a 0 that is the lowest common multiple of all of these numbers, or essentially all these numbers when you simplify down a bit for prime factors. So it's a bit of work, but it's probably better than what I did. You can have a look in the mark scheme for that method there, but that's how I did it. I was quite happy with my method. The answer was 13. 25, I would say probably the most difficult and involved question on this list here. just had to be very clever with it. Maybe if you had lots of time at the end of the exam, you'd have found it. What this is saying is 4 peaks go all the way to Q, so I can just finish the drawing for them, I guess. I don't know why they didn't finish that drawing for you, but I'm going to finish for them. It works in the same way like this. Of course, it doesn't really look like it because they printed this deliberately badly. But of course, if these 4 peaks all do this and end at this point here, this must be the midpoint of this semicircular arc here. So that must be the midpoint, which means that this distance here is a radius. So, and because of course this is a radius, because this is the central point, that makes this whole angle there alpha, because this is an isosceles triangle and it has alpha at the bottom, so that's also alpha. Now, what about this angle here? Just this angle here? Well, that must be, because this is a triangle at 180 minus 2 alpha, that must be 180 minus 2 alpha. And now I'm going to consider this angle, so if I get rid of this alpha here and consider this whole angle there, that must be, looking at a straight line, 180 minus alpha. So that must be that angle there. And now I've got to look at this angle, and I can think, well, okay, here's another triangle. I think this angle here is 180 minus this minus that, which actually ends up being 3 alpha minus 180. So okay, seem to have made some progress here. I'm trying to find alpha. I haven't quite got there. I need one more spark of inspiration. And what that is to think, well, this side here is a radius, and so is this side. But this is an isosceles triangle here, because this used to be alpha, remember, before I got rid of it. So if that's if this is an isosceles triangle, then this length is the same as that one, which is the radius, as we've said. So these two things are the same here, because this is just an isosceles triangle. But the key here is that this is a radius also, and so is this. So actually all 4 of these are the same length. They're all radiuses. And that's really helpful, because now if I look at this length, well, that must be the same clearly as this length, because it's another isosceles triangle. So that must be the same as this length, but it's also the same as this length here. And the reason for that is, if we go back to this statement for a little second, we actually have 2 congruent triangles. And this is the key spark of inspiration. This triangle here and this triangle here are congruent, because they have 2 sides the same, and they also have 2 angles of alpha on their base. So these 2 triangles, the one at its side here and the one standing up right here, are congruent, which means this side here must be the same as this side here, which is also the same as this side here, because of isosceles triangle in the corner here. And that's our key moment here, because now we realize if this here is an isosceles triangle because of the double dashes here, then that means this angle, which is that, is the same as that angle, which is that. And we can sort that out, and we'll solve for alpha, and we'll finish this exam. Quite a nice one, quite enjoyed doing it. Really well done for sticking through that, and thank you for watching.